This lesson involves inequalities and absolute value. You've solved any absolute value equations. You've solved compound inequalities. Now we're just putting those two things together. We'll solve a less than and a greater than. And there's a key little phrase that you can help you remember if it's supposed to be an and or an or. If I see a greater than, think about greater. Greater is or. So greater is or, and that means that they don't have to have anything in common. And then less than is and. Less than is and. So there's an and. That means that they will have the common areas shaded. So when you set up an absolute value inequality, you actually use a compound inequality. So you write one that looks exactly like the inequality without the absolute value bars. Then you write the word or, and then on the second one you still write what's inside of the absolute value, but you flip the inequality, and then you change the sign on what the expression is, greater or less than. So flip the inequality, change the sign. Here's an example right here. 4x plus 5 is greater than 7. Then the absolute value of that, you'll write 4x plus 5 is greater than 7. No absolute value bars. And then 4x plus 5 is less than instead of greater than, and instead of 7, it's negative 7. For the and, you can write two separate statements, or you can write an inequality like this. If you write two separate statements, which would be a little bit, I think, easier to make sure you do it right, you'll do ax plus b is less than c. Okay, that looks just like the absolute value without the bars, and then you write the word and then ax plus b is greater than, so flip the inequality and change the sign on the c. You can write it either way. You can write it as a compound statement like we practiced the other day, or you can write it as two single statements. All right, so here are some examples here. Graph the solution set on the line as well. So this is a greater than, so we can see that this is going to be an or. So we'll start with 2x minus 2 is greater than or equal to 4, or, and then 2x minus 2 is a less than or equal to negative 4. Now you just solve. So we'll add 2. We have 2x is greater than or equal to 6, and then we divide by 2. And x is greater than or equal to 3, or, and then go through the same process. Add 2. We have 2x is less than or equal to negative 2. Divide by 2. X is less than or equal to negative 1. So this is an or. They don't have to have things in common. So if I put a 0 here, negative 1 is just to the left, and 3 is just to the right. And you can see, remember that these tell you which direction to shade. These will both be closed circles. I'll pick a color. So closed here, and then we will shade to the left of negative 1, and this x is greater than or equal to 3 shades to the right of 3. So there is an or. Greater is or. Less than is and. So two ways to write that. You can write the 3x minus 3 is less than 9, and then you can just come right into the front and do another less than and put a negative 9 out in front. Or you can write it as 3x minus 3 is less than 9, and let me move this out of the way a little bit. There we go. And 3x minus 3 is greater than negative 9. So either way you want to do it is fine. since I have this one set up where I have some space to work, and we'll work this way, but you know how to solve these because we did this the other day. So add 3, because we're going to work from the center. Add 3 to the center and work on the left and the right. -6 is less than 3x is less than 12. Divide by 3. So we have -2 is less than x is less than 4. What's nice about this is you can see that you're shading in between these two numbers. We have zeros right here. Here's our -2. Here's our +4. These are going to get open circles. I'll just use another color. So open, because no equals on there, and then they will shade towards each other in the middle, in between the two. And that is solving absolute value inequalities. Here are 2 problems for you to work and solve and bring back to you with you to class the next day.